So let's talk about another major application of the Pythagorean theorem, which is finding the distances between 2 points on the coordinate plane. As a friendly reminder, our coordinate plane is a flat surface that has 2 axes running along it. Our horizontal axis we call the x-axis, and our vertical axis we call the y-axis. The y-axis is vertical, like a yo-yo. The y-axis is horizontal, like a xylophone. We choose to have these 2 axes meeting at a right angle, which means any perfectly vertical line and any perfectly horizontal line will also meet at right angles. All these grids are at 90 degrees with each other. They meet together at a point that we call the origin. And we give it the coordinates 0, 0 to represent that it is 0 units along the x-axis and 0 units on the y-axis. It is our starting point from which all the other points are measured. Remember that coordinates are always given as an x value and a y value, where the x shows how far to the right, or if it's a negative number, to the left of the origin you are, and the y value shows how far above, or if it's a negative number, below you are up to the origin. So if we have a point that is 1, 2, 3 units over and 1, 2, 3, 4 units up, we can call this point 3, 4. Since it is 3 units over, and it is 4 units up. Y coordinate of 4, x coordinate of 3. But because of how we find our axes, we know that these 2 lines meet at a right angle over here, which means we can approximate this point using a right triangle. This side down here, its horizontal side, is its x-coordinate, 3 units away on x. This side is 4 units up. And the distance it is from the origin is going to be the hypotenuse of a right triangle. Well, we know that for any right triangle, the sum of the squares of the legs has to be the square of the hypotenuse. We know in this case we have 3 squared for x, 4 squared in y, should be the square of whatever that distance is. This means that the square root of 3 squared plus 4 squared should be that distance. The square root of 9 plus 16 is the distance. The square root of 25 is the distance. 5 is the distance from the origin to the point. This gives us our first little formula. The distance from the origin to a point can be expressed as the square root of the x-coordinate squared plus the y-coordinate squared. Because the point forms a right triangle where the distance we're looking for would be the hypotenuse. Now that's relatively straightforward. But what if we have 2 points that are not the origin? And what if, shocker of shockers, one of them had some negative values? So we're going to consider 2 points here. We're still going to look at 3, 4. 1, 2, 3, 1, 2, 3, 4. And now we're going to look at -2, 1. These coordinates mean that the point is 2 units to the left of the origin on the x-axis and 1 unit above the y, or 1 unit up in y. We want to know what this distance is. Well, if you're super sneaky, you might have seen, hey, we still have a right triangle in play here. It just doesn't happen to go through the origin. We just need to know what are the lengths of these two sides, and we can figure out what the length of this hypotenuse would be. Well, let's take a look at this point here to get to this line. In order to get to the point originally, we had to go 4 units up. But we're not going to go all the way down to the x-axis. We're only going to go down to this line that intersects this point, -2, 1. This point is 1 unit above the axis. So instead of going all 4 units down to the axis, we're only going to go 3 units down to the axis. And if you look at our grid, we can verify our answer, 1, 2, 3. So this right triangle has one leg that is 3 units up. Now what about this distance? This point is 3 units away in x, to the right. To get to this one over here, we have to go an extra 2 units. Altogether, this length should be 5. But here's a cool thing. With our y-coordinates, we did the y-coordinate of point 1 minus the y-coordinate of point 2, and we got a change in y. Here, we're going to do the exact same thing. We're going to take the x-coordinate of point 1 and subtract the x-coordinate of point 2 to get a change in x. 3 minus -2 does indeed equal 5. So we are looking for the hypotenuse of a right triangle, 1, 2, 3, 4, 5 units in the x direction, and 1, 2, 3 units tall in the y direction. Well, I know it's a right triangle, so I know the Pythagorean theorem is in play. I know my length here is 5. I know my height is 3. I do not know what c squared is, but I know that the square root of these numbers should get me c. But an important thing to note here is this is not going to be a friendly number. This is going to be 25 plus 9, i.e. the square root of 34. That is not a perfect square, but our calculators can give us a nice approximation for it. C is about 5.831. For this unit, if you are getting a non-perfect square, you need to go to 3 decimal places to keep things beautiful and precise. So we can take our original formula, which was the distance from the origin to a point, and we can adapt it now for going between any points. So this is the distance from point 1, call it x sub 1, y sub 1, to x sub 2, y sub 2, can be given as follows. Distance equals the square root of the difference of the x's plus the difference of the y's. We do the subtraction to figure out what are the lengths of the sides of this right triangle, and then we use the Pythagorean theorem to solve for the resulting distance. This distance formula trips up a lot of students. There are a lot of small places where it's very easy to make a mistake. Some key ones to consider. First, you have to do your subtraction before you square it. We need to find the length of the side before we can plug into the Pythagorean theorem. So that means I do the subtraction of the x's and then square it. I do the subtraction of the y's and square it, and then I add them together. Additionally, watch for your signs. We do subtraction between the 2 points, and then we add these 2 squares together. If you want to break it down into its individual processes, that is perfectly mathematically fine and valid. If you're the type of person who makes a lot of sign errors, it might be best to break it apart for right now, and then use the formula once you get more used to how these numbers interact with each other. The last thing to be wary about are how negatives interact. 3 minus negative 2 is 5. This distance is longer than just going back to the origin, and so my number should be higher as a result. The very super duper last thing you need to worry about is you have to be consistent with which point you label as point 1 and which one you label as point 2. In this case, this one we called point 1. We took point 1's y and subtracted the other y coordinate. We took point 1's x and subtracted from the other coordinate. It doesn't matter which one you label as point 1 or point 2. When they get squared, their negative signs will go away. But if you describe this one as point 1, its x-coordinate should also be the one that you subtract from as well. If you swap this one compared to your y's, you're going to get an incorrect value because you've broken the assumptions that the formula is based on. So, to recap, the distance from the origin to a point, xy, is just the square root of x squared plus y squared. If we're trying to find the distance between 2 points, we have to find the difference of their x's and the difference of their y's to get the side lengths of the right triangle, and then take the square root of the sum of the squares of those sides to get the distance, which is the hypotenuse of that triangle.